We're going to dive into plenty of more complex EIGRP configs here in this particular section. First video is going to be a little heavier on theory because we need to go over some packet types. And let's start that with a more detailed look at the packets that frankly make everything happen. EIGRP uses the Reliable Transport Protocol, RTP, to handle guaranteed and reliable delivery of EIGRP packets. And the phrase guaranteed and reliable should bring something back from your CCNA or CCNP studies. It sounds like TCP, right? But the two are quite different in how they operate because not all of our EIGRP packets are going to be sent reliably, and it might surprise you as to which ones aren't going to be sent reliably. Now the hello packets, we're all over that one. They handle neighbor discovery, they serve as a keep alive for established adjacencies, and they're multicast to 224.0010. Now the ACK packs, or the acknowledgement packets, they're simply hello packets that don't carry any data. Now neither ACKs nor hellos use RTP, and they're considered unreliable. So that's right, you're thinking, well, the most important packet of all is actually unreliable. They are considered unreliable, hello and ACKs. Now update packets, they're sent to new neighbors, and they allow that neighbor to build an accurate routing table and a topology table. They're also sent upon a change in the network. Now update packets are generally multicast packets, but this is networking, so we got to have an exception somewhere, and more on that in just a few minutes. Now query packets we talked about at the end of the last video in the EIGRP fundamentals section. They're sent when a router loses a successor and there is no feasible successor for that particular route. Now if we get an answer, we hope we get one in the form of a reply packet. Those are responses to queries, and reply packets indicate that that route that we were asking for, a new route to the destination in question, has indeed been found. Now reply, update, and query packets all use RTP and are all considered reliable. I think that's a good thing to know. I smell an exam question there. And to see how many of those packets have gone through, period, you can run this command, show IP EIGRP traffic. And I've got something set up on the lab for you. We'd look at it there, but we actually see more of them here. It's just show IP EIGRP traffic. It's going to show you your hellos, updates, queries, replies, and ACKs. Now, when the query, update, and reply packets remain the same, then your network is stable. You know, you're in good shape. And it doesn't matter if the updates go up a little bit if you add a neighbor or something changes in the network. But if you see them constantly incrementing, you've got an issue in there. What you might have is what we call a flapping link. And that's a link that is up 1 minute or 1 second and then down the next. And then up again and then down again. And the query and reply values increment only when a successor is actually lost. So when you see those continually incrementing, you know you've got an issue in there somewhere. Let's talk about the initial route exchange with EIGRP. And the festivities begin when EIGRP, first off, is enabled on a serial interface in this case. And EIGRP hello packets are then multicast to 224.0010 naturally via that interface. And what happens is it's an attempt to find potential neighbors. And in this case, router 2 receives the hello, and if certain values are agreed upon by the two routers involved, R2 responds with an update packet. And that packet contains all the EIGRP learn routes that router 2 knows about. Here's the exception to the update packets being multicast. They're usually multicast, but in this particular instance, it's going to be unicast back to that new neighbor. Now, what happens now is that router 1 sends an ACK back, an EIGRP acknowledgement packet back to router 2, and it lets router 2 know, hey, you know, I got those routes you sent me, thanks very much. Router 1 then sends an update packet of its own, unicast to router 2, containing all the EIGRP routes that R1 knows about. Then R2 answers with an ACK of its own, and the initial route exchange is complete. And again, from your fundamentals, you know this, but just a quick mention of it again, EIGRP routers, this is the only time they exchange full routing tables. After this, they'll only update each other when there is a change in the network. Now, we could have some adjacency issues pop up on the exam and in the real world as well, so let's talk about that for a moment. And we're going to talk about this hold time deal with EIGRP. Now, the EIGRP hold time has the same function as the OSPF dead time, because if we have these packets going around, and we do, with EIGRP and OSPF, we know that routers have to receive hellos at a regular interval or within a fixed interval in order to keep an adjacency up. Well, if that's the rule, and it is, we have to have a timer. We can't just say, okay, if we don't hear a hello in a month from that other neighbor, then we'll drop the adjacency. We're not going to give it that much time. And with EIGRP, again, it's the hold time that defines the amount of time in which a hello must be received in order to retain that neighbor relationship. Now, the default EIGRP hold time is 3 times the hello time, and I mentioned on the board more on that soon, but I'm pretty sure you can tell what the hello time actually is, but we're going to work with it on the live equipment here shortly. Now, something that might surprise you. Unlike OSPF, the hello and hold timers in EIGRP do not have to agree between potential neighbors in order for them to become neighbors. Now, it might cause problems, and I can guarantee you it would over time, but they don't have to agree on these timers in order to become neighbors. And we're going to prove that on the next video. We're going to do a lab. We're going to put routers 2 and 3 in their own little autonomous system and mess around with the configs a little bit. But before we get started with working with those, we need to know what the current timer settings are, right? They're slightly hidden in EIGRP. They're not as easy to spot, but the command you want is show IP EIGRP interface detail. And there's some great information here beyond the timer. And we'll just take a quick look at this before we go on to the next lab. And I just ran show IP EIGRP interface detail, and that's going to give me all of the interfaces on the router that are currently running EIGRP. And this is router 1 from our previous labs, and this is the one we're going to take out of the lab for the very next video. But right now, since we have it enabled here, let's take a look. We have loopback 1 up there, and you can see there's a hello interval of 5 and a hold time of 15. And notice on serial 10, hello interval is 60, hold time is 180. So it's a lot different for an NBMA interface than it is for a loopback. And also we can see the split horizon is disabled because we did that on the serial interface. And these numbers could be a little tricky because, you know, you're looking at serial 010. It's like, what's this 2? What's this 0/0? What's this 933 sitting here? Well, the column actually starts up here and it kind of goes through the output for loopback 1. So if you're looking at this and it's multiple screens, you're just thinking, okay, what's this 2? Well, that's the number of peers, the first one. And of these values, that's really the only one we're concerned with here. The pacing time, that kind of thing, we're going to save that for even more advanced studies. But that's a good way to see the number of peers. You can also see that something called an authentication mode is not set. That's a teaser. You might see a little something about that later. But right now we are just a little bit more concerned with those hello times and hold times and how to spot them. So let's move on down here. I believe we're getting right into the lab. This is what we're going to start with the next video. I'll set this up during the break. We are strictly going to work with routers 2 and 3 and their Ethernet segment. We're going to keep the IP addresses the same. We'll run 172.12.23.0/27, and of course those addresses will end in 2 and 3 to match the router numbers. So we will, on the very next video, I'll have that set up for you before we start, and we'll work with those hello and hold timers a bit.